In a similar vein to Dave, I'm going to talk to you about a couple of projects or key project highlights that I've had in my year. I've had the opportunity to work on some fantastic projects, but I'm just going to bring you a couple. The first of which is the Heartlands project for HS2. This covered the demolition of a 100 meters stretch of road bridge in Saltley, which is near Birmingham. The bridge was removed over 4 weeks between August and September to make way for the northern section of the HS2 phase 1 route between London and the West Midlands. The work was carried out by Jonathan Regeneration, and they were the demolition contractor, and they were working for the main civils contractor, who was the joint venture of Balfour Beatty and Vinci, BBV. The subcontractors were Podtrack, who looked at protecting the rail tracks, but also included us, who we provided the temporary works design for the demolition works. You can see the bridge there on the right, and it had 3 spans, the central span being over the railway line. At Andon, we were acted as the demolition specialists, assisting John F. Hunt with the demolition methodology and the temporary works design. And we designed the track protection, which went over the railway tracks, which was constructed of a layer of geotextile over the rails, and then some fill core blocks and then timber mats that allowed excavators and plant to work over the track without damaging them. We also provided the 3D sequence drawings that assisted the John F. Hunt in producing and describing what it would be, and they also included that into their RAMs. We carried out the bridge stability assessment too, and our philosophy on this was to reverse the construction sequence, which was outlined in some of their archive drawings. This was a project where we had quite a lot of archive information, which is not something that we always have the benefit on all projects, but this one we had them, so we were going to put them to good use. And because we had the knowledge of how the original designer envisaged that the bridge would be constructed, i.e. which spans would be inserted and which sequence, that means that we could reverse that sequence, which reduces the risk that's involved with stress changes or support condition changes. That means that part of the design had less risk, and we also proved that the sequence worked ourselves, but it's always a good idea to maintain the established load paths in a structure. We also produced the Form 2.3 that was required for the Network Rail submission. And then another item that we designed was the temporary stability system of the structure that was during the dismantling sequence, which I'm going to just talk a little about here. So one of these systems is shown in, on the right-hand side, and this was required as the head restraint and the diaphragm bracing of those steel beams was removed, and we wanted to ensure that they remained stable whilst they were being prepared for lifting. And the detail was to run a strap from 4-ton bags of ballast up around the flange through a hole in the web and then back round to another 4 bags, which was on the other side. And this effectively prevented the tall, skinny beams from toppling over. We also carried out the crane position, which is shown up on the top right-hand corner. And it's worth noting at this point that the pads, because we were operating adjacent to railway, it's requires adding on an additional factor required on top of the outrigger load, which is in accordance with the CPA guidance, which is pictured at the bottom there. So this is a factor which is over and above any partial safety factors that's required for design codes. And the CPA guidance states that the load should be multiplied by a factor of 1.33 to increase the level of safety of the foundation absorbing those loads. And you can also see here where we've shown the lifting sequence and weights, which were then incorporated into the RAMs. The final stages, once the majority of the structure was removed and the span was taken away from that sat over the railway lines, we had the span 3, which was removed using mechanical demolition methods, so a larger excavator and breaking out the concrete, and then the steel beams were removed using a controlled collapse mechanism with a plastic hinge. So the beam is cut by a burner from the bottom up, and eventually the self-weight of the beam causes the beam to sag onto some pre-prepared debris stockpiles, and then it's processed and demolished. And that was the theory. We've got a video here which kind of shows the works in practice. So you can see here they're taking out the parapets and the concrete structure by mechanical means. And then once the deck was removed from spans 1 and 2, then we could come in with the mobile crane and start lifting some of the steelwork away. You could see there some of the diaphragm braces between the steels, which provided lateral stability, but they had to be removed to enable the beam to be taken out. And that's the final span coming out there. So now from